Alright, hell yeah. So today we're going over sequences and how to see if a sequence is converging. And one of the things that you can do is you can take a sequence like this and you can simplify it. You can divide the top and bottom by n squared. And so what that gives you is something that looks like this. So if I divide this top part, the numerator, by n squared, then I'm going to have n squared over n squared, which is 1, minus 1 divided by n squared. So that's what we would have there. And then the denominator, very similarly, we're going to have that. And then the question is, if we have n goes to infinity, when we can easily prove that this will be 0. 1 divided by a very large number, this becomes 0. And then we can see that the limit of this sequence as n goes to infinity is 1. And so that's kind of what we're going to explore today. And hell yeah. Okay, so and then I just wanted to break it down as in, why can you do this? Is because you can take any equation and multiply the equation by 1. And I should probably say more formally, what we're doing is we're taking the entire equation and kind of multiplying it by 1. So this is, in fact, 1 right here. And then so I could multiply the other side of the equation by 1. I'll actually have to research when you are doing something to an equation, you know what I mean? Yeah. It seems like this is more formally what you'd want to do. But hell yeah. Okay, so n squared divided by n squared is 1. But in this, written like this, it's kind of hard to see that this n squared is, you know what I mean? This numerator is going to be divided by this n squared. And this denominator is actually going to be divided by this n squared. And so, so let's show that by dividing both sides by 1 divided by n squared divided by 1 divided by n squared. So now this thing right here is still 1. From the previous page we had n squared divided by n squared. And so now we can see that this, you know, if we multiply the numerators together and then multiply the denominators together, now we can easily see that this numerator gets divided by n squared, as well as the denominator gets divided by n squared. And we can take a look at this. This is the same thing divided by the same thing, so this is 1. And so, so we're good to go there. And so, yep, so that's what we're going to do. And then, so this becomes n squared divided by n squared minus 1 divided by n squared. That's the top part. The bottom part is n squared divided by n squared, 1 divided by n squared. Cool. And then so this is 1 and this is 1. And then this didn't change. And now we can now we can take n to infinity and see that this value becomes 0. Alright, hell yeah. So now the question is, does an converge as n goes to infinity? And so it's not quite obvious from the setup where you just have the sequence as n squared minus 1 n divided by n squared plus 1. I would have infinity squared minus 1, infinity squared plus 1, infinity divided by infinity. I don't know, is it 1 or is it something else? You know what I mean? And so, so this is unclear. But if we divide both the numerator and the denominator by n squared, then we have 1 minus 1 divided by n squared. And when this term gets real large or goes to infinity, then we know from a proof that this term is 0. And so that's where we get that the fact that this sequence converges at 1, and that's going to be the answer for this. But I think the take-home nuts and bolts is to see stuff like this. Hey, I don't want to change the equation, but I do get to multiply something top and bottom. I get to do the top and bottom. I can do whatever I want to the top and whatever I want to the bottom, because that's essentially multiplying this by 1. And so that was the gist, to get it into a different form that we can easily see that this goes to 0 as n goes to infinity. Alright, hell yeah. So thanks for joining me on this one. Booyah.